All right, lesson 102. So absolute value, guys, first of all, just remember that absolute value is a distance from 0. So even though if it's like negative on a number line, it's still a positive distance. So distance always has to be positive, okay? So absolute value always makes things positive because it's how far away from 0 is something, all right? So let's say that I have the absolute value of x is equal to 2, okay? What are the two solutions? What could x be? Yeah, so what's the absolute value of 2? It's 2, so that's one of the solutions. What's the other one? X could also be negative 2 because the absolute value of negative 2 is positive 2. So if I were just doing a number line, it would be those 2 points, negative 2 and 2, because this one is equal to. All right, those are my two solutions. All right, now I have x is less than or equal to 3, but it's the absolute value of x. So let's just think of some numbers that work. The absolute value of what is less than or equal to 3? 3, 2, 4 does not work. 1, 0. How about negative numbers? What works? Negative 1, negative 2, negative 3. All work, right? What about negative 4? No, because that'd be positive 4, which is not less than or equal to 3, okay? Now, you're not going to have to just guess and check, right? I'm just having you like think through it. So the procedure that I use is I branch it out, and all of the ones on the homework are going to be inequalities, okay? Absolute value inequalities. So what we want to do is we isolate our absolute value. This one already is isolated, okay? So the absolute value of x is by itself. If there's an extra step in there, I'll show you, okay? And then I'm going to rewrite this one exactly the same, but without the absolute value bars, okay? X has to be less than or equal to 3, but that's only half the answer, all right? On the other side, and I always say branch it out, and I put my 2 arrows because there's 2 pieces to this, okay? The positives and the negatives. On the other side, we get rid of the bars, okay, the absolute value bars. We flip the inequality, and we make that number negative, okay? So every time you will both flip and make this negative to get the other half of the answer, all right? So in other words, my solutions are less than or equal to 3 and greater than or equal to negative 3. So if I draw a number line, it is going to turn into either an and graph or an or graph. Do you guys remember the and graphs and the or graphs? Okay, the or graphs point out. The and graphs are in between 2 numbers. So if I have less than or equal to 3, let's say this is domain reals, that goes this way. And then I also have greater than or equal to negative 3, that goes this way. So this turns into an and graph where I'm in between 2 points. And the best way to write this is negative 3 is less than or equal to x is less than or equal to 3. And for an and graph, I would like you to write your final answer where x is in between negative 3 and 3. This says the exact same thing, right? Notice this part of the equation looks exactly the same. We did flip this whole thing. If x is greater than negative 3, negative 3 is less than x. That means the same thing, okay? We just write it as in between. All right, let's try x is greater than 2. Greater than 2. Okay, let's just think through it. I know you're not going to think through it on the homework, but let's just think through like what works, okay? What's greater than 2? What numbers work? 3, the absolute value of 3. Okay, what else? 4. Okay, so anything above 2, right, would work on the positive side. What about a negative number that works? Do any negatives work? Negative 3 works, right? What's the absolute value of negative 3? Positive 3, which is greater than 2. Okay, how about negative 4, negative 100? Does that work? Yep, because then it goes positive, and 100 is greater than 2, okay? So let's follow the procedure that I want you to follow, okay? You would isolate the x, the absolute value part, which it is, okay? And then we would branch it out, all right? And we write our 2 answers. One of them is exactly the same, but without the bars. It has to be greater than 2. And for the other one, we flip it and make the 2 negative, okay? So everything above 2, let's say this is domain is reals, I would do an open circle. This is greater than, so it shades this way. Open circle on -2, this one is less than, so it shades that way. Notice this turned into an OR graph, okay? The OR graphs point out. I'm going to teach you a little trick. What is this symbol right here? Less than. I'm just making that up, okay? I made that up right there. Less than and graph, okay? So less thans will always turn into an and graph, okay? And this one right here, what's this symbol? Greater than. Get it? Greater than. It's an or graph, okay? Every time. That's how it will like work, all right? So it should kind of turn out like that, although you can just follow the process, you'll get the same thing. Okay, let's add some extra stuff, because why not? Let's do some algebra with this. So write this down. Negative absolute value of x plus 3 is less than or equal to -1. Now, I don't know until I isolate this if it's a less than or a greater than, so this might flip, right? Okay. Anyways, I want to isolate the x. The first thing I have to do is get rid of this plus 3. So I am going to subtract 3 from both sides, of the inequality, okay? So this goes away. I have negative absolute value of x is less than or equal to -4. Okay, -1 minus 3 is -4. All right, now I have this annoying negative sign right here. This is just like having a -1. So I'm going to divide both sides by -1, which leaves me with the absolute value of x is less than or equal to +4. Okay, now we branch it out. And I want you to show me both solutions, okay? Even if you memorized, did I mess up, you guys? Yes, I did. Thank you, everyone. I divided by a negative. What do I have to remember to do? Thank you so much. Yes, flip the inequality because I divided by the negative, okay? Great job. Now we want to branch it out. So actually, though, just to think through it, what symbol is this now that I flipped it? Greater than or equal to. So what kind of graph am I going to get? Or graph, okay? But I want to see both sides of this. So you are going to write x is greater than or equal to 4. And for the other one, what do I put? Less than or equal to -4. Exactly. So then I'm going to do solid circle on +4. This one's greater than, so shade right. Solid circle on -4. This one's less than, so shade left. And it is an OR graph, just like my inequality said after I remembered to flip, okay? All right, let's try one more. Okay, the absolute value of x minus 5 is less than 3. So we start by doing what to get the absolute value by itself? Add 5 to both sides of the inequality. And so I get the absolute value of x is less than 8. Okay, so it is a less than, what kind of graph am I going to get? And, okay, and we must remember to write both. If you don't write both, you don't get full credit, even if you do the graph right. So you got to do x is less than 8, stays the same. And the other one, we flip the sign and make the 8 negative. Now this is telling me that my values are both less than 8 and also at the same time greater than -8. So I need open circles on -8 and 8. And again, less than goes this way, greater than goes this way, so I'm shading in between. And yes, I want you to write your final answer as an and statement, which a lot of people don't like to do, but you want to write it like this: -8 is less than x is less than 8. They will always be less than signs. That is just saying x is in between -8 and 8. Okay, yes? Right, the OR graph doesn't have an extra step. You can write the word or in between if you want. I would do that. I lied, it was not the last one. Here's the last one. Okay, negative absolute value of x is less than or equal to -4. So again, this is just like having a -1. I need to divide by -1, which then gives me the absolute value of x is greater than or equal to 4. So I remembered to flip, okay? It is a greater than, so what's my graph going to look like? or graph. So you got to write your two statements, okay? Remember to, like I always say, branch it out, which means write your two different answers, okay? And then I have greater than or equal to 4 goes this way, less than or equal to -4, and my lovely or graph, okay? There are some weird cases, okay? Two special cases that you want to recognize. And right off the bat, I want you to notice something about these numbers. They are both what? Yes. If that number is negative, it's a special case. You have a problem. All the ones we just did, we literally ended up with a positive at the very end. This was a +4. This was a +8. This was a +4. Like once we solved, okay? We had a positive. So if you have a negative, it is a special case. Let's think about why. Okay, what would work? What's greater than -3 if I plug in a number? Let's see, if I plug in -2, I would get +2 is greater than -3, so that works, okay? What else? Okay, -1 works. How about +100? Yeah, the absolute value of 100 is 100, which is greater than a negative number. What is this absolute value always going to do? Create what kind of numbers? Yeah, I'm going to get positives every time. No matter if I plug in -100, it's going to turn to +100. So everything works. Like every single number works. Okay? Yeah, even -4 because that becomes +4. Even -3 works because -3 becomes +3, right? Everything becomes positive, and is every positive number greater than -3? Like every positive number is greater than -3. So this is like true no matter what. The solution to this one is all real numbers, like everything, and you would literally shade the entire number line. Okay? Because everything positive is greater than a negative number. Every positive number is greater than a negative number. Okay, how about this one? Now we're going the other way. This is the other special case. What would work? What would work? You guys are right. Nothing works, okay? If I plug in anything, I'm going to get a positive number. You guys agree? This is going to make anything positive. Like, let's say I plug in -100. I'm going to get +100. Is that less than -4? No. There are no numbers less that are positive, because everything's going to be positive here, that are less than a negative number. So this one would be no real solutions. And we would have an empty number line, just like a blank number line. Okay, those are the special cases. All right, let's try some whiteboard.